What does a digital resilient future look like? Whether you are running your network, running your apps, running your workflows or your security. Look from all different kinds of perspectives in your organization. I'm going to show you different types of demos from either manufacturing, sports applications, flight simulators, but also AI-driven applications, how to run a resilient operation and how to make it successful. Now, let me show you how it works in a manufacturing plant. And here we have a guitar. Here is a robot. The robot stems the guitar. First it checks if it's out of tune. If it's out of tune, then it starts stemming. So you can see the robot moving, it's checking it. And there's a lot of data collected from the robot itself, of course, which is used for maintenance, for predictive maintenance. You hear that now stemming. If it's out of tune, it stems it. This data is sent to the Splunk hub, which you can see in the dashboard. And there's also all kinds of robot data checked, especially for predictive maintenance, sent to the hub. And if there's an anomaly detected, they can start the predictive maintenance part. Let's move to the next part. Here we have the overview on one hand where we have the security and the operational statistics and dashboard, where it's on one hand, for example, the error rate, all the operational dashboard and data, which is the IT and the OT operation, but all collected in one overview. So based upon all this data, it's made actionable depending on whether there's anomalies on one end from the robot, but also, for example, anomalies which you can see here on the guitar, which has a scratch, which will be on the next station that we're going to detect. Now let's go to the next station.
Yeah, I don't.
No, but again, I told you.
So here we see the next station where we have a visual inspection. So you see a scratch over here on the yellow guitar, and there's a visual inspection depending on the different type of checks that are done, and where it checks if whether it's defects or whether it can pass the test with all the visual inspections, which you can see over here. You can see the yellow one has a scratch, it's detected, and if it doesn't pass the test, it's going to the separate line where all the defect guitars are further processed, and the ones that are passed basically have an overview and go to the final line and can go to the packaging system. So this is all running on the Splunk Edge Hub, which collect all the data from the robots and from the visual inspection and send to the Splunk central system for further processing and making the data actionable. Let me show you the next one. Here we have a very nice one, which is a football prediction engine. And I'm here with the developer from the football prediction engine. I'm here with Young.
Hi, nice to meet you.
Good to meet you. You developed a football prediction engine. Very nice. We just already worked on it. We created a
I
team.
see you do have your lineup up here.
Yeah,
Yes, that's
I
correct.
just created a team. I hope I'm gonna win. But of course, what's much more interesting than, let's say, doing the bet is what's behind it and how does it work, and how can you bring with machine learning this type of experience in a resilient, safe, secure way.
Absolutely. Well, the way we did this and how it kind of works on the back end is, well, when we first approached this challenge, we were thinking about what kind of approach we wanted to take, right? And a few things came to mind first, and that's exactly as you said. We wanted the data to be resilient, we wanted it to be lightweight, and we wanted it to be secure.
Yeah.
There's a lot of talk these days about using LLMs for every single task, and they certainly have their place. But through experimentation, we found that using classical modeling, specifically using a couple of different random forests to predict different things, gave us very, very good results for NFL data. And the way we did this is through Splunk's backend. We used something called the machine learning toolkit. So we were able to ingest so much data into Splunk from many different data perspectives. We were able to get data from NFL's official sports broker called Sports Radar. We were able to get data from meteorological sites or like weather forecasts, things like that, and we were able to correlate data from a lot of different sources as well. With Splunk, we were able to get them to speak the same language. And once they're on the same platform with the same language, we were able to use the machine learning toolkit, which is our out-of-the-box. It provides a lot of out-of-the-box algorithms. We applied that to our data, and it makes doing machine learning and making these predictions very, very easy.
And basically what I've done here, I created my prediction. So I had a budget of $50,000. I purchased different type of players, and your algorithm is doing the same. And we're betting basically against your algorithm and see who is going to win. And that's what we're going to figure out in the coming week.
Absolutely.
And can you explain me a little bit as well what's behind it? So what's the engine behind it?
Yeah, absolutely. So our first step, good machine learning comes out of two things, right? Clean data, voluminous data. So our first step was talking to the official sports broker of the NFL called Sports Radar. And we got a bunch of data about the players, about their opponents. We looked at different sources. We got data about the weather. We got data about historical performances, everything in one platform. Now that we have all the data in one platform, what we were able to do is we were able to use something out of the box in Splunk called the machine learning toolkit that has a lot of algorithms available for people to use on the data within that platform. And because it is available out of the box, because we have a user interface that makes it very easy to use, what we were able to do is apply every single algorithm, test a ton of different parameters, and through a multi-step process, not just isolate the most important fields, correlate all the data about who they're playing and their opponents, and then lastly, make a prediction where we can test the error. We were able to predict their future points within 5 points of their actual score. We were able to test how accurate it is and then use that to make a very, very powerful prediction. The model we happen to use is called the random forest regressor.
Yeah.
This is not because I chose one or I had some favorite. We were able to test every single algorithm in the machine learning toolkit just because it is simple to use, and from that, pick the best score.
Perfect, perfect. Yeah, and now you have a great interface which you can use. Is it just for fun, or you also use it commercially?
Oh, of course we use it commercially. So this actually kind of stemmed from the idea that we do predictions very well. We have customers using the machine learning toolkit to predict fraud in banks, right? To predict ATM fraud, for example. We have other companies using it in manufacturing to predict when machines are going to fail. We have other companies using it to, for example, we have car companies using it to do quality testing. We have universities using it to improve their security detections. I think, don't quote me on this, I think it's from 2% to like 98% once they adopted LSTMs. So we know we're good at this. But then the question was, these are systems that are somewhat predictable. How well will we do when we take it and apply it to a system, American football, which is notoriously not predictable at all. So this wasn't, hey, if we can predict this, we can predict your data. It's, we know we can predict your data. We know what is possible. We have done it. How well would it perform? With a challenge.
Yeah, and this is quite a challenge. But we're going to see next week who's better.
Absolutely.
Thank you, Young.
Thank you.
Thank you. Now let's go to the next station. So Young explained us very well how to create a betting prediction engine. Now let's see with Kendrick, who created a flight simulator, and how he used the telemetry data to give you the insights that you want to see how you perform. And this can be applied, of course, to your business as well in any type of environment where you have telemetry data. Let's discuss with Kendrick. So how to explain complex type of applications just by gamifying, which makes it very easy. Hi, I'm here with Kendrick.
Hey.
You're the developer of this flight simulator.
Yeah.
Basically what you do is using the telemetry data and you put it, you collect it, you store it, and you visualize it so everybody can see how well he performs. But maybe you can explain a little bit while showing how you fly this, what is it, an F-16 or?
This is an F-18 Super
F-18.
Hornet.
Wow.
Yeah, so it's effectively, my friend and I, Paul, who developed this, we're really big fans of simulator games, and we like playing games like this. Now, this particular game in Microsoft Flight Simulator, you have to fly as low as possible and get to the goal that you can see in the distance there. And the lower you fly, the higher points you store. Now, we thought, let's get this data out into Splunk. And now, fortunately, Microsoft Flight Simulator has a really good SDK. So we connected Splunk up to the SDK, we poll the data on 1 second intervals, and we send it into Splunk's HTTP event collector, which then allows us to visualize it on the dashboard over here. So you can see real time my G-force, the wind direction, My airspeed, my altitude, and my mission score, which is the most important metric, is being sent over to Splunk.
Yeah, so you have all the telemetry data, and this is of course a game, it's fun,
Yeah.
and it's nice, but if you compare it with real business, this is exactly showing what you can do with all the telemetry data, show it in real time, make it actionable, and people can either see the situation or even can take action based on it.
Absolutely. The key takeaway message for the people that are visiting this booth is it doesn't matter what it is. If it's running on a system or a computer or a server somewhere, we can get that data out. We can put it into something valuable like a dashboard, alert, or in a report, and you can do whatever you want with it.
Yeah, either train yourself or find anomalies or whatever
Absolutely.
you have in the end. It's great. So let's see how your score is going to be at the end. If you're going to be the champion today.
Well, I'm not allowed. I've put too many hours into this, so I shouldn't really record a high score because I don't want to knock people off of the leaderboard. Maybe I'll just fly right to the goal, but
Yeah.
you know, a good score's around 1 million on this game. The top score we got so far is 1.5 million from the event over the 2 days, but I think that'll be beaten. I think someone will reach 1.6.
Exciting. Thanks, Kendrick.
No worries.
Happy flight.
Thanks very much.
Thank you. And last but not least, moving from Kendrick, from his flight simulator, go to the AI section. Resilience with AI and resilience for AI. So let's dive in. What are the possibilities with AI to get a resilient environment for your organization? So one part, of course, is the AI part, where AI, of course, can help with malware analysis and do some threat investigation. I'm here in an overview where there's an example, for example, from incoming emails. So where the AI helps with the analysis, it detects it, and then explains what is the chance, basically, that this is malicious software, and the steps that can be taken or will be taken once the file is executed. And as a next step, the AI also gives a recommendation from the steps that you can take. And on the other hand, it's the tactics that should be used to, let's say, solve and remove the malware. And then you have the recommendations how to solve it with suggested next steps. So the action still is human, but the AI helps in real time to detect any malicious type of emails, like phishing emails, for example, to prevent that they can either, that somebody opens it or can basically damage your systems. I hope you enjoyed the demos as well. I really love them, to give you an insight how to build a resilient business with AI, for AI. This was from Splunk.conf in Boston in the United States, and looking forward to seeing you next time with some next series of really amazing innovations in the domain of AI.